Alright, I gave you this polynomial. You're going to list out all the possible zeros. We're going to factor it. And then today's lesson, way down here, we're going to try to solve it. Okay? Kevin, how do I find all the possible zeros? Okay. What's your last one? Wait, going too fast. 1, 3, 1, 2, 4, 8?
Yeah.
And they're both positive and negative, right? Okay. Good job, Kevin. Ruben, tell me all the numbers we're going to test. Yes? Remember, they call these all possible rational zeros, is because they're either whole numbers or fractions, and there's no radical signs or imaginary or complex. And then we have to test all these that are negative too, right? Okay. There must be some secret or shortcut to figure out which one to test, because I really don't want to test all of these fractions or test all of these numbers. Does anyone know something that might help us? Cynthia. Yes. You graph it. You came up with that brilliant idea on your own? Let's graph it. What? A graphing calculator. Amazing. Okay, Cynthia. I graphed it. Cynthia. Now what? Second calc? Oh! We're trying to calculate zeros, huh? Go left, right, exact. Class, what is that? Which is what? It told us the answer. Cynthia recognized that I don't have to test all of these numbers, huh? It actually tells me where to start. Let's do the second one. Second calc. Go down to 0. To the left, to the left. To the right, to the right. Stop. What is this class?
Negative 3/4.
Cynthia knew a secret. Now, well, that's part of Vang, isn't it? You have an equation. Algebraically, we're doing stuff. Graphically, and we can also look at a table. Now, this is a little bit more difficult. Second graph. Think about it. If you put in 0 into all this, what does your y-coordinate become? -3. If you use the remainder theorem, This is your output or your remainder. So you didn't have to like test all the numbers. This can actually tell you where they are. For example, let's see if it works. 0.5. No, can't press it. So I'm going to have to go to second table set. No, wrong one. Second table set. Independent, I'm going to press ask. Press enter and make sure it's highlighted. And then I'm going to go to second table. And then I can type in those numbers. 1/4. Class, does it have a remainder of 0? No. Is it a factor? No. Let's try negative 0.25. Class, does it have a remainder of 0?
No.
Is it a factor?
No.
No. 0.5. Yep. Class, does it have a remainder of 0?
Yep.
Is it a factor?
Yep.
Yeah. That tells me where to start. So some students say, well then, does that have to mean I have to show you all the possibilities of why they don't work? No. You can show me by synthetic division the ones that do work. Let's do that together. One half. I've got 8, 2, 5, 2, and negative 3. Now, I still have to do synthetic division. I already know what the answer is. What's the 0? What's the answer? 0. But let's do it. And I need something from this. Bring it down. 1/2 times 8/1. 1/2 times... Oh, wait. We need to add first. 1/2 times 6/1. 6/2, which is 3. Add these. 1/2 times 8/1. 4 plus 2. 1/2 times 6. Negative 3 plus 3 is 0. Remember, I already knew this worked. Okay, what do you think we could do next? We already knew that 1/2 works. Should I test other numbers? What number should I test? Negative 3/4. Let's do it. Now, I already have these numbers. You see this? You're essentially going to use these numbers again. Let's use a different color. And now we're going to use negative 3/4. Bring this down. I'm just multiplying the tops, the bottoms, and divide. 3 times 8. 4 times 1. 24 divided by 4. It's going to be negative, right? 6 plus negative 6. 0. Negative 3/4 times 0.
Wait, aren't you missing a 2?
But now we're using, okay, so someone asked me, are we using the original numbers? Now I'm just using these numbers. Because remember, think about it. This is a constant. This is to the x. This is x squared. This is x to the third. And I'm reducing the polynomial in its degrees. Do you see what's happening? And I'm trying to get it down to at least quadratic, or at least something I can do. Now, if you notice, you have 8 and 6. 8 and 6, that's actually really good. You can probably just factor in by grouping. But I want to show you guys that using the rational roots theorem continually can still work. Negative 3/4 times 0. 8 plus 0. Correct. You'll see. This is the result. You're correct. Negative 3/4 times 8. And 6 plus negative 6. 0. Okay. What does this mean? if x equals 1/2, what's the binomial? I'm going to multiply both sides by 2. I get 2x equals 1. How do I get a set equal to 0? We're going to subtract. So I get 2x minus 1. How about negative 3/4? X equals negative 3/4. I want to set this equal to 0. How do I do that? Multiply both sides by 4. 4x equals negative 3. Add 3. 4x plus 3. Okay. What does this 8 represent? Say again? Constant. Good. How about this one? Zero x. And what does that 8 represent? 8x squared. Let's clean that up. 2x minus 1, 4x plus 3, 8x squared plus 8. I can take out GCF from right here. Class, what's the greatest common factor? 8. So now I have 2x minus 1, 4x plus 3, and what's left in there? X squared plus 1. Okay, so this would be our answer if I said factor completely. If I said factor completely. But let's just go one more step and show you guys what it means to find all zeros. So this is today's lesson. How do you find all the zeros of the polynomial? Where does it cross the x-axis? Without just punching it into your calculator and getting an answer. Well, let's think about this. Class, what's another way of saying the word zeros? Roots, x-intercepts. Partner B tell partner A, what's the order pair for an x-intercept? Ready to go. Class, what's the order pair?
X0.
Number, then 0. So it's saying if I put this whole polynomial equal to 0, I can find the x-intercepts. Why do you do that? Well, if I cover this up, 8 times something, or this finger, or this finger, or that shape, one of those has to be equal to 0. So what do? We're going to set them all equal to 0. This is kind of weird. We already did the math for 2x minus 1. It's just going backwards, yes? So it's just x equals 1/2. We already did the math for 4x plus 3. What is it? X equals negative 3/4. Okay, so I got a couple of them. Class, can 8 equal 0? No. We say no solution. So we don't actually use that. We got an answer, x equals 1/2. X equals negative 3/4. They would call these real zeros. All right, take a look at this one. X squared plus 1. Class, how do you solve for x? You want me to square it? Square root. X equals I plus or minus. Class, how many solutions is this? Count with me. Ready, set, go. 1, 2. This is really just I and negative I. Okay? Let me bring in the whole picture now. Ready? 1, 2, 3, 4. There are 4 zeros in this answer. We found that 2 are real and 2 are complex. I can use the rational roots theorem to figure out what are all my possible rational zeros. We can use the calculator instead of helping us test all of these individually. I can get these answers. I'm reducing the the degree of the polynomial. We started with a 4th degree. This is essentially a 3rd degree, and it gives me power of 2 until I can keep reducing or factoring it. This is what we've done previously, is to factor completely. But in today's lesson, all I'm asking you to do now is find all the zeros. Your answers would be 1/2, -3/4, and plus or minus